Welcome everyone. In this video we're going to be looking at the various receiver options and configurations available to us PowerBox users. So at this point in time, for this example, I'll be using a PowerBox Mercury SR2. I currently don't have any receivers connected to it, but we're going to connect a few various receivers in a few different configurations to give us an idea of what options are available to pilots who use PowerBox systems. Okay, let's turn the Mercury on. And I'm only using the one power input for this example. No need for dual battery redundancy for our video. So on the little OLED screen which comes with this unit, you'll notice there's 8 volts indicated on the left hand side of the screen. So that's my LiPo battery. On the right hand side you'll see 0 volts. There's also a current consumption indicator which is showing about 20 milliamps. There's also a battery capacity indicator which you can program up to count either up or down. And I'll explain those features in a later video when I delve deeper into the features of these PowerBox units. However, for this video we're really interested in the receiver display status screen here. So you notice it toggles between RX1 and 2, and it just shows a little horizontal dash indicating there's no receivers connected. So if you watch my previous video, all these units, so for instance the Mercury, the Competition SR2, the Royal SR2, and even the PowerBox Pioneer unit, which is another unit I own, a pretty handy unit as well, they feature dual redundant receiver inputs. So you can have 2 receiver inputs. If one fails for whatever reason, the PowerBox itself can still receive data from the other unit or the other receiver, and in theory should still function fine. Okay. Let's switch it off and let's plug in a receiver. So let's start off with the most basic configuration possible. I'm not saying it's the most usable one for you, however it will work, and that basically means we use a PowerBox satellite receiver. So the PBR26XS is designed to be used as a satellite option. However, it can also be used as a fully fledged functional full channel receiver. And the reason being is because it can decode from my core, for instance, all 26 channels and output them along this single cable as a serial data stream configured as a P2 bus connection. It also has a fast track configuration, so you can reconfigure this port as fast track. You can also configure it, say, for S-bus. So if you have typically it might be a Futaba peripheral that allows S-bus input. This receiver can output S-bus from here, and that's all programmable from your core or Atom transmitter. It's pretty easy to do. Just go into the menu items for this receiver and change that option. However, for this example where we're going to use it with a Mercury, this basically is set up as a P2 bus connection. Okay, let's hook it up. It's got a bit of blue tack on the bottom of it to hold it in place. I'll just stick it roughly here so it's visible to us. And hopefully the lead reaches okay. Let's plug it into the RX1 connection. And I'll just move the cable out of the way a little bit so we can see the receiver and the screen. And let's apply power to the Mercury. And you'll notice it's basically in binding mode because I haven't bound this receiver. And while it's in binding mode, this receiver is not really outputting any true channel information along the P2 bus connection at the moment. So you'll notice a little warning pop up on the screen indicating signal. There's something wrong with your signal. So if you had, say, both receivers connected to the RX1 and RX2 ports, you'd get this same indication, say if your transmitter's off, or both receivers are faulty, or both receivers are not bound. Let's bind this receiver to my core. So I don't have the core on screen, but the binding process is pretty simple, and I did cover it off in one of my earlier videos. So I'm just binding that receiver now, and you'll notice it's bound. The blue lights come on solid, so hopefully that you can see that okay on the video. Sometimes the LEDs don't show up all too well. However, also look at the screen here. So you notice RX1 is indicating OK. and RX2 is still a dash because there is no RX2. So as far as the Mercury is now concerned, we have a fully functioning system. If I had a servo connected to one of these ports and I programmed it up to one of my sticks, I could move my stick and the servo would respond. However, like I said earlier, it's probably not the best configuration to use with a Mercury, having a single antenna, a single receiver, sort of fraught with a little bit of danger here if you're using it in a big model. I wouldn't recommend it for a large model. And obviously for a small model, you probably wouldn't be using, say, a Mercury or a Pioneer or any of those configurations. So it's probably not a configuration a lot of us would use. However, I just want to show you in the video that it is an option if need be. Let's switch it off and connect a second receiver. So the next step up from a 26S is to use two of them. So let's add another 26XS, bit of a tongue twister there. And we'll connect this one up to the RX2 port. So same deal here, nothing too out of the ordinary. Now I'll just move these wires out of the way of the video. Hopefully they'll stay there. Let's switch power on, and I'm pretty certain this one's not bound either, so you'll see it flashing away when I first apply power. And I'll just quickly bind it to my core just by hitting the bind button. It goes through the bind sequence, and now we have a solid blue light on the second satellite receiver. So don't forget, these satellites are now being used as fully fledged receivers. Both of these are outputting all 26 channels from my core through their respective cables into the RX1 and RX2 connections into the Mercury. So as far as the Mercury is concerned, it's getting the full complement of 26 channels. Now don't forget, the Mercury has 16 PWM outputs, so we could use, say, channel 25 on my core and output it on one of these. Well, typically you might just use 1 to 16, and you might not use the other channels, but there is that virtual channel feature where you can reprogram the Mercury to output any channel within the 26 channels of the core on any one of these sets of servo PWM outputs. Simple as that. So now, this configuration gives us two receivers. So we've got redundancy there because we actually have two separate receivers, and two RF redundancy paths. So we've got two antennas. So this is a valid configuration, and it could be a reasonable configuration if you had some oddball aircraft where you needed to use a Mercury, maybe you had lots of servos in it, but you had next to no room for a larger receiver, and you wanted to tuck one of these receivers, say in the aircraft wings for instance. These are pretty thin, they're a very small unit, so you can compare it to my fingers here, extremely thin devices. So very easy to mount these, say, in a vertical tail plane or a horizontal fin somewhere in your aircraft. But that's not really their primary role. But it is, like I said, it is an option. So once we've got this configuration, what's the next option for, say, a larger aircraft, a mid-size aircraft? What would you really use? Okay, let's switch these guys off, and I'll just remove them from the Mercury. Toss these guys away, well, not literally. I'll just remove the blue tack, put that aside, and let's get the next option, or my preferred option, is to use a PBR 26D. I'll just position this guy over here, stick it down with the blue tack, hold it in place. So the 26D. The connection as far as connecting it to the Mercury is concerned is identical to the 26S. We use the P2 bus, so this servo port on the 26D is not programmable, it always functions as a P2 bus. Just recall that the fast track and data port is a multi-programmable port, so not only is it fast track, we can program it for other features as well, like S-bus, output, etc, etc. However, in this case, we're going to use P2 bus because that's what the Mercury needs on its RX1 port and RX2 port. So let's connect the servo lead to RX1 port, and let's just quickly bind that to my core because I don't think it's bound. So apply power. Notice the green fast flashing LED. If If I hit bind on my core, it is now bound to my transmitter. And again, you'll notice on the display, on the little OLED display, you'll notice RX1 OK and RX2 is non-existent because of the dash, and therefore the Mercury is happy with this setup. Now, what's this setup give us? Well, it gives us a redundant path on the receiver, on the actual RF side I should say, not the receiver. So we have two individual RF paths. You've got two antennas, and just to reiterate, with the 26D, don't forget these feature two full independent receivers inside the one housing. So you've got two separate RF preamps, two separate RF receiver circuits, and basically they're fed out, or the data from those is fed out as a 26 channel bus system into the Mercury. So all the 26 channels from my core appear along this little single cable into the Mercury. So the only drawback with this configuration is that we don't have any redundancy as far as this link is concerned from the Mercury to the actual receiver. So for instance, if this cable's near my exhaust or my turbine and it melts, catches on fire or whatever, I'll lose this connectivity to this receiver and the aircraft crashes. So you don't have a redundant connection as far as the Mercury is concerned. However, we do have true RF redundancy on the receiver side of things. So don't forget, we have separate RSSI figures for both of these receivers. We have separate frame loss figures, separate link quality. As far as the software is concerned, these two receive paths are treated fully independently. So technically we have two receivers connected to the Mercury. However, like I like to stress, there's no redundancy between the Mercury and the receiver at the moment. So typically, if you're flying a mid-size or larger aircraft, you wouldn't just use one 26D. It's a bit silly. I mean, the cost of the aircraft's going to be crazy compared to the receiver, so it's just cheap to buy another receiver. It's just a no-brainer. You'd use a second receiver. So let's do that. Let's connect another 26D. Now, same thing, except we're going to connect this one to RX2. So it's the same deal here. We're using the P2 bus connection out of the receiver, plugging it into the RX2 port of the Mercury. And let me reroute these wires so they don't obscure the receiver too much. Hopefully they'll stay there. And I'll just apply power. And I think I have to rebind that receiver as well. Just hit the bind button on my core. And there we go. Both receivers are now bound, indicated by the solid green light. Both receivers have P2 bus connection into the Mercury. So remember, each one of those receivers is feeding 26 channels worth of serial bus data into the Mercury. So now we have a full, truly redundant receiver setup. If one of these receivers goes bad, or one of these units goes bad, the cable gets cut or whatever, the Mercury can still receive valid data, channel information from the other unit. And also, because these feature two receivers each, we now have four receivers, or four redundant RF paths. So I could theoretically say cut each one of these antennas off and just leave one, and providing that one is still receiving a valid signal from our transmitter, the Mercury won't care, it'll still function normally. So we've got redundancy from the receivers into the Mercury, and then you've got multiple path redundancy as far as the RF path is concerned. Cool. Okay, that is a pretty good setup, and you probably find 90% of pilots might use this configuration. If you had a very large aircraft, or you wanted that extra little bit of security that PowerBox System provides, we can go a couple of steps further. So what's our next option? Well, remember the 26XS. Remember these guys here I was just showing you earlier? Well, this is where they come into play in a good way. So remember, these units are pretty thin compared to all the other receivers. Fairly tiny, fairly light. It's very easy to install one of these in a tailplane, for instance. So what if we want to use one of these as well? Well, we can. Let's turn power off to the system again. So now what we do, instead of connecting this up directly into the Mercury, we connect it up to an existing receiver. So any of the receivers that feature a fast track port have this function where they can accept an input from a satellite receiver. So what's going to happen now is the 26XXS is going to be reconfigured for satellite use. And by that I mean this cable that I'm plugging in. Remember how we're using it before plugged into the, if I plug it in around the right way, we're using it with the Mercury. It was basically working as a P2 bus connection. So from this point to the Mercury it was P2 bus. However, now in the satellite configuration, we have to connect it to the fast track port of the 26D. This cable here now is a fast track connection from the 26S. It's no longer P2 bus but fast track. And that's an important distinction. These cables here, obviously in this video, are short. However, whether it's the fast track bus or the P2 bus, you can run a couple of meters, no problems at all, like 3-4 meters. The data will still function fine. They're actually designed to work over longer distances. So like I said, if you mount one of these guys up in your, say, your tailplane, say on your vertical stabilizer, you know, you tuck it up inside there and it's a large aircraft, and you've got a 3 meter run to it, no dramas at all. Okay, let's switch it on. Now, because I've already bound that receiver, it should come up bound already on my core, which it does. So now what happens is we have a fast track connection from this receiver. So this is fast track output into this receiver. Now, as far as the Mercury is concerned, it doesn't really care that an extra satellite receiver is connected. It doesn't even really know there's a satellite receiver there. However, we can access all the parameters like RSSI, frame losses and everything from your core or Atom radio for all of these receivers. So technically what we have now is 5 individual RF paths. We've got a receiver there, receiver there, receiver there, receiver there, and a 5th one here. So that gives us a lot more RF diversity. As far as diversity back into the Mercury is concerned, we still have the 2 cables. So we've got the dual RF or dual receiver diversity. However, we've now improved the system performance because we have an extra RF path. And if we want to go sort of the ultimate step with this current setup, we can bind another receiver. So we can add an extra satellite. So you can add 1 satellite per main receiver. So we can add this to the second PBR 26D down the bottom here. If I manage to plug it in correctly. The cable's getting in the way there. And turn it back on again. Now all receivers are bound because I bound these earlier. They're staying bound to this particular model that I've got set up on my core. So now we have 6 RF paths. We have 6 fully independent receivers. So 1, 2, 3, 4, 5, 6. And basically each one of these satellites feed back into each one of these receivers, or main receivers if you like. And then the P2 bus connections from those main receivers feeds into the Mercury. So as far as the Mercury is concerned, if, say, you know, these 2 receivers are blocked for whatever reason, or the antenna cable falls off your receiver, that receiver stops functioning, and say that one stops functioning, the data from the 26S might still be valid because its antenna is okay and it can still see your transmitter alright. That spits out data via fast track, comes into this receiver on its fast track connection. This receiver then outputs that valid data out of the P2 bus into the Mercury. So the Mercury, as far as Mercury is concerned, that's a seamless operation. Chop off these 2 antennas, Mercury doesn't care. It still functions okay because it's still seeing valid data on this cable. And that's basically how the system's designed to work. So not so much of an issue of the antenna getting cut off, but more so if your antenna gets blocked, you know, from poor orientation, or if a fuel tank's in the way, or some, you know, your engine or your turbine's in the way when the model's facing in a certain orientation. You really want, whenever you set these antennas up or position these antennas in your aircraft, you really want at least a minimum of 1 antenna to always have visibility, no matter what orientation your aircraft's in, back to your transmitter. Simple as that. If you've got at least one of these being able to receive a valid TX signal from your transmitter. Any one of these receivers will be able to decode that data and output it to the Mercury, and the Mercury will be, happy as Larry. Won't cause a lockout. That's the theory. Also, let's have another look at the display here. You'll notice now, because we've got two receivers connected, I can't remember if I mentioned this before, we have an RX1 OK and an RX2 OK, so that's happy. Both receivers are functioning. Okay, one other thing to mention. I'm using a core radio. The core radio can bind up to 4 receivers. So even though there's 2 receivers in one of these housings, as far as the binding process is concerned, this counts as one bound receiver. So it's got dual receivers in it, but when you bind it, it's just handled as one receiver in the binding scenario. The core radio can bind up to 4 receivers in its current state. So basically 1, 2, 3, 4. If you have an atom, you can't bind all these receivers at this point in time. You can only bind a maximum of 2. So you wouldn't be able to add these 2 units to these main receivers, the 26Ds, and bind them all together like I have done, unless you have a core transmitter. So just something to be aware of. Okie dokie, that's a good setup at the moment. I'd just like to mention on the grapevine, I did read on the forum, PowerBox forum, that PowerBox are supposedly working on a firmware update to the 26Ds. So this will apply only to the 26Ds as far as I'm aware. At the moment, the only satellite option is to use one of these 26XS receivers, which is a single antenna type device. However, PowerBox, like I said, are doing a firmware update, or looking at working on a firmware update to convert these into a satellite functionality type receiver option as well. So if that comes to fruition, in the future we'll be able to use the 26D as a satellite, and that might open up another opportunity insofar as we can actually probably plug a 26D into a 26D, no different to this satellite. However, that'll give us 2 extra receivers, so in theory with a core radio you could have up to 8 fully independent RF paths if we're able to use a 26D as a satellite. But for the time being, these are your go-to options for satellite use. Okay, I might just switch those off, and I might just remove from my model the satellites. So I've just unbound the satellites from my model on my core transmitter. And let's take the satellites out of the equation. Just remove that as well. And let's see what happens when, for instance, with the Mercury, I know in the bigger units like the Competition and the Royal, we have more servo PWM ports. So if you've got a large scale machine and you want to use, say, 20 channels and you've got a Competition, not a problem. The Competition can handle 22 channels. If you've got a Royal, that can do the full complement of 26 channels coming from the core. However, with a smaller brother like the Mercury, or even a Pioneer, the Pioneer can handle 14 channels or has 14 PWM outputs. The Mercury has 16 ports here, if you count them, 1 to 16. But what happens, you put this in a slightly larger model and you need 17 channels, or you need an extra 2 or 3 channels, or 4 or 5 channels, because you've got some scale figurines, or you want to activate some lights, or just some scale features. You may not necessarily want to drive servos, but you want to, activate a few little functions. With this setup, you've only got the 16 PWM outputs. And if that's not enough, what can you do? Do you need to go buy a Competition? Well, before you race out and spend money on the Competition, there's another trick you can do. And what you can do is get rid of one of these 26Ds and just get rid of that bit of blue tack. And let's put in place a PBR 9D receiver. So we're going to connect, oops, bit of a tongue twister. We're going to connect a PBR 9D. So what's the 9D all about? Well, the 9D is just really a standard receiver with PWM outputs. So it's got 9 servo pins, or 9 sets of servo channels there, or PWM outputs. And this can give us a few outputs for some scale features, for instance. So as far as the Mercury is concerned, it doesn't really care that a 9D is connected in place of a 26D. In fact, the 9D is pretty much identical to a 26D. It features two antennas, so we've got two independent receivers. So as far as that functionality is concerned, it's identical. RF performance is the same. The only advantage of a 9D is that it gives us these PWM outputs on the side here. So we connect it to the Mercury. I'm just going to connect it to the RX2 port using the P2 bus connection. And our 9 servo outputs are here. With this particular receiver, it is a 9/10 channel receiver, so users of this receiver are probably aware that you can program up its fast track port to operate as a 10th channel, PWM channel that is, if you need to. You don't necessarily have to use it, but if you needed that 10th channel, you can set that up in the core transmitter screen or the Atom screen and program that as a 10th output. However, for this setup, let's just turn it on. We're just going to use the default 9 setup. And you'll notice it's not bound to my core, so I'll just quickly hit the bind button and bind it to my core. And there you go, you've got the solid green light, so now it's indicating that it's bound. The Mercury's happy, it sees RX1 and RX2, not a problem at all. So again, P2 bus, no different to the previous 26D, straight into the Mercury. So again, as far as the Mercury is concerned, it just sees that pretty much like an identical 26D. However, now we have 9 PWM ports. And so what's the use of that? Because, you know, I've got channel 1 to 9 here, and we've got channel 1 to 16 here. Well, you know, remember that with the 9D, we can program the start channel. So this A1 here, typically it's channel 1, or the default is channel 1. However, we can tell it to start at whatever channel number we like. So I could tell it to reprogram this using my core to tell it to start at channel 5 or 6, 7, 10, whatever I like. So since the Mercury is using, say, 1 to 16, don't forget we don't have to actually use 1 to 16. You can set up virtual channels. So for instance, we can set up channel 24 on my core to appear on the first socket. It's pretty much programmable to whatever you like. However, typically most users might use 1 to 16. We can tell this receiver to reprogram this channel 1 to start at 17. So once we do that, the channel count on here will be 17, 18, 19, 20, 21, 22, 23, 24, 25. So we can access those other channels via a PWM output. And if you want the full complement of 26, you can even reprogram the fast track port to act as a 10th channel. So basically you'd have 10 channels starting at channel 17, which gives us the full complement of 26 channels from my core radio. Again, the only redundant thing with these channels is concerned is we have RF redundancy. However, we don't have receiver redundancy. Because remember, your servo is going to plug here, or whatever you're going to control is going to be plugged into here. So you're not going to have a second receiver, physical receiver. You only get that on these outputs. You don't get it on these outputs, of course, because it's just basically the one receiver unit. So you still have your dual receiver diversity. So for 99% of cases, that won't be an issue. And typically, you wouldn't have your critical flight surfaces on here. You'd probably have, like I said, you might want to have a movable pilot figurine type thing. You could plug those channels in from here and not tie up the Mercury channels. If you had a lighting system, you might want to use the output from here. So like I said, if you had a scale machine with various light functions and that, you might have multiple lights, multiple figurine movement, all that sort of stuff. Plug them into here so you don't tie up these channels here. You use these channels here for your critical servo flight surfaces. And just be aware that the current flow through this cable is limited. So the current output on the RX1 and RX2 ports is limited. So you don't really want to be powering high current servos, like I've got some Futaba A700s, and they're pretty gutsy servos, 70 kilogram servos. They draw a bit of current. You don't really want to be powering them off here. I'd be powering them off here. So again, for scale applications, it's just a handy feature to be aware of. So also don't forget, if you've got a core, and we can bind up to 4 receivers in total, we can add satellites to this configuration as well. So the 2 satellites that I previously used before, we can hook one of these up to the 26D, no different to what we had before. So that's self-explanatory, and because I removed it from the binding from the model before, I had to just had to rebind it again, and same with this guy. So just remember, on the 9D, if you want to add a satellite to it, it's not a problem. However, this fast track port, we can't use it for the 10th channel option because it has to be configured as a fast track connection. So remember to program it up as fast track. So now we only have the 9 channels or 9 PWM ports available to us. However, if I recall correctly, I have got it programmed up as fast track. Just plug the receiver in there, or the satellite receiver. You notice it's flashing away because I removed the bind before. So I'll just quickly bind it again, and away we go. So again, back to having a full complement of 6 RF paths for my core radio. So I've got a fair few receivers as far as the transmitter receive paths are concerned, and we still have our dual redundancy back into the Mercury. So I've got these 2 receivers acting as like a main or primary receiver connection into the Mercury. Okay, that will probably be enough to wrap up this video with. In my next video, I want to cover off telemetry sensors and the interconnection of telemetry sensors. So similar video to this, however, we're going to be dealing with telemetry sensors. A lot of people get confused on how to hook them up, and also when you need to hook up more than one sensor, you know, how do we do it? Do you use wire leads or not? You know, that sort of type of thing. And I'll also cover off the important aspect if you're using 2 or more of the same sensor, what you need to be aware of as far as the addressing of the sensors is concerned. So that'll be in the next video, so hopefully you guys will look forward to that. Anyway, thanks all for watching, and yeah, if you have any comments or questions, just leave them in the video comments section and I'll reply to them when I can. Thanks all for watching.